Okay, so this is going to be lesson 8, 9. And we're going to split this up between today and tomorrow. That'll be the last lesson for Unit 8, and then we will continue with Unit 9. So today we're going to be solving equations with rational exponents. Tomorrow we'll be dealing with the inequalities. So we want to go ahead and move on to this. So just take some time to read this portion right here. Common mistakes to avoid. These are just some things to keep in mind when we're trying to solve these problems today. And then also just remember, go ahead and read this on your own as well. That remember how you can write a radical into a fraction form. So that way it can help us out with today's lesson. Now for today, this right here are going to be the steps that are going to help us out when solving the problem, which is pretty similar to the ones when we had roots. We still need to solve for x. How? Well, we have to use PEMDAS. And then remember that you can also cancel an exponent by multiplying it times the reciprocal. And then when you do to one side, you do to the other. And last but not least, check your answer, okay? So with that being said, we are going to go ahead and move on to example number 1, where we want to solve 2x to the power of 3/4 plus 2 equals to 10. So I'm going to go ahead and I'm going to write SWBAT right here to the side to help me figure out what it is that I have to do first. Well, do I have subtraction? No. Addition? Yes. You get rid of addition by doing what? Subtracting. So I'm going to subtract this from both sides. This here cancels out. So now I'm going to have 2x to the power of 3/4 equals to 10 minus 2 is 8. So now we move on, okay? Do I have division? No. Multiplication? Yes, but it's inside the parentheses, so I can't do anything with that yet. Exponents? Yes, I do have an exponent right here, okay? An exponent of 3/4. So now what I want to do is I want to get rid of the exponent. I'm going to go ahead and put some big parentheses right here. And I'm going to go ahead and get rid of the 3/4. Well, how am I going to do that? Well, I told you over here by doing the reciprocal, okay? You want to multiply times the reciprocal. So if you have 3/4, the reciprocal of that would be flipping this, which would now be 4/3. So I'm going to multiply this by 4/3. And then what you do to one side, you do to the other side. So now by doing that, this right here cancels out. So now you're going to have 2x equals 8 to the power of 4/3. Now here, you may not know what 8 to the power of 4/3 is, but you can go ahead and you can convert it to radical form, okay, which means the denominator is the index, so that means that I'm going to have a cube root of 8 to the power of 4, okay? So now I'm going to get, okay, so I'm not going to try to multiply 8 4 times because that's just too much. So I'm going to try to do the little trick that we did a while ago when we were separating them. So I'm going to go ahead and I'm going to do the cube root of 8 to the 3rd times the cube root of 8, right? Because if I do 3 plus 1, that is going to give me 4. And the reason why I want to do this is that I separated them according to the index that I had. Okay, guys? So according to the index that I had, it's this right here, 3. So I wanted to group this in groups of 3. But 4 can only be separated into groups of 3 once with 1 remaining, okay? Now, by doing this and this cancel out, meaning that I am going to be left with 8 times the cube root of 8, which is 2 times 2 times 2, right? Because then that'll mean 8 times 2. So now I'm going to have 2x equal to 16, because the cube root of 8 is 2. Because you can have the cube root of 2 cubed, that cancels out, leaving you with just 2. So now I have that. And then we go ahead and continue with SWBAT. Do I have parentheses? No. Subtraction? No. Addition? No. Division? No. Multiplication? Yes. Divide by 2 to both sides. X is going to equal 2, 8. That right there would be my answer, but once again, we need to check our work. I'm just going to check it here. Okay, and make sure that you are using the original equation. Okay, we want the original equation, which means this one right here. Okay, so now I'm going to get 2 times x, but now my x is 8. So I'm going to put 8 to the power of 3/4 plus 2 equals 210. So that's going to be 16 to the power of 3/4 plus 2 equals to 10. 16 to the power of 3/4 is going to be 8 plus 2 is 10. 8 plus 2 is 10. Does 10 equal to 10? Yes, it does. Therefore, this is true. So this right here is a real solution. Moving on to the second example, we are going to solve x plus 30 to the power of 1/2 equals to x. Okay, I'm just going to go ahead and rewrite this right here. So I'm going to go ahead and I'm going to solve this using SWBAT. Okay, do I have subtraction? No. Addition? Yes, but the addition is inside the parentheses, so I'm going to skip that one. Division? No. Multiplication? No. Exponents? Yes. Okay, my exponent right here is this 1/2. So now I'm going to go ahead and multiply times the reciprocal of that 1/2, which is 2 over 1, or 2 divided by 1 is literally the exact same thing as just 2. So what I do to one side, I do to the other. So now this right here cancels out, meaning that now I'm going to have x plus 30 equals to x squared. Okay, so now to have parentheses, no. Subtraction, no. But I do have addition. I have 2 additions, so I'm going to go ahead. I personally, myself, just like to keep anything that has an x squared positive. So I'm going to subtract the x, and I'm going to subtract the 30 to the other side. And now if you look at this, this turned out to be a quadratic equation, which we solve by using tic-tac-toe or the tabular method. So once again, it's coming back to us, okay? So we're going to go ahead and we're going to solve this quadratic equation. And the reason that I know it's a quadratic is because I have a power of 2. I'm going to go ahead and solve this using tabular. So I'm going to do a little box. Okay, where the x squared goes in the first box, that negative 30 goes on the outside. So I have to go ahead and figure out what times what equals to negative 30, but adds to negative 1x. So I can automatically think about 5 and 6, but now I need this to be negative, okay? And when added, I need it to equal to a negative. So that means that the negative 6 should be negative and the 5 should be positive, because then that will equal to negative 1x. So I'm going to go ahead and put the 5 and the negative 6. So that's x and x, positive 5 and negative 6. So these two are going to be my answers right here. Set them equal to 0. Solve for x. Okay, Now, one of these is going to be real, one of these is going to be extraneous. So we have to go ahead and figure this out because you cannot have two solutions. It's either going to be one or the other. So let's go ahead and figure this out. So we're going to check this. So I'm going to have negative 5 plus 30 to the power of a half equals to negative 5. That's going to be 25. Which this also means like a square root of 25. What's the square root of 25? 5. So does 5 equal to negative 5? No, that's this is false. So therefore this is the extraneous solution. So this is going to be my real solution. And that right there would be my answer. Okay? Okay guys, I have more examples for you, but I'm going to go ahead and go through those tomorrow. I'm just going to leave you with those two right there. I think that's more than enough content for today. Okay? Have a good one. Bye.